Okay, what if you could teach a machine to master literally any task? I'm talking winning a crazy complex video game or navigating a chaotic city, all without giving it a single instruction. Well, that's the incredible promise behind one of AI's most powerful ideas, reinforcement learning. And today, we're going to break down exactly how it all works. So let's start with the central puzzle, right? How do you teach a machine to make smart decisions when there's no instruction manual? I mean, think about it. You've got a robot, you want it to learn something new, but you can't just hand it a textbook. So what do you do?
Well, the answer, surprisingly, isn't buried in lines and lines of complex code. It's actually a process we see all around us every single day. It really just boils down to the simple but super powerful idea of trial and error.
You know, the best way to get this is to think about something really simple. Teaching a dog a new trick, right? You don't hand your dog a manual on how to sit. Instead, the dog just tries stuff. It stands, it lies down, maybe it barks a little, but then, just by chance, it plops its butt down. And in that exact moment, you give it a treat. That treat is a positive reward. And after you do this a few times, a little light bulb goes off in the dog's head. It starts to connect the action of sitting with the reward of a treat. And believe it or not, that simple feedback loop, that's the engine behind reinforcement learning.
Okay, so let's take that really simple idea and translate it into the language of AI. We can actually break down that whole dog and treat scenario into the core components that make this whole thing tick. So in the world of AI, our dog is what we call the agent. The living room it's trying to figure out, that's the environment. The agent learns by, doing stuff, taking actions in that environment and getting feedback. A reward for a good action like a treat or a penalty for a bad one. And its one and only goal is to come up with a strategy that gets it the most rewards possible over the long haul.
And this whole thing creates a continuous learning loop. It goes like this. 1. The agent acts. Our dog sits. 2. It sees what happens in the environment. 3. It gets that all-important feedback, a treat. And 4, it updates its own internal strategy. It's basically thinking, okay, sitting gets me good stuff. I should do that more often. Now imagine this loop repeating not just a dozen times, but millions or even billions of times. With every single cycle, the agent gets just a tiny bit smarter.
Now, this is a really important point. This is a fundamentally different way for an AI to learn. We're talking about a huge shift from learning by instruction to learning purely by experience. Let me give you an analogy. The more common type of AI, called supervised learning, is kind of like studying for a test with the answer key right next to you. You're just memorizing the right answers from a book. But reinforcement learning? That's like learning to ride a bike. No textbook in the world can teach you how to balance. You just have to get on, try, and probably fall down a few times. That's your penalty. But you keep adjusting, you keep trying, until finally, you're doing it. And that success, that's the reward. And that right there is the absolute superpower of this approach. See, a textbook full of answers is totally useless when the real world gets messy and doesn't play by the rules. But an agent that learns from experience, it doesn't need a book. It can adapt on the fly and figure out solutions in all kinds of chaotic, unpredictable situations. So this all sounds great in theory, but where is this powerful idea actually being used? Let's take a look at how reinforcement learning is making the jump from theory to the real world. Honestly, the applications are already incredibly broad. We're talking about teaching robots how to walk on rough, uneven ground, optimizing these massive, complex global supply chains, creating financial trading strategies that can react to the market in real time, and yeah, it's a huge part of the decision-making inside self-driving cars. Let's take a really practical example, like a delivery routing system. In this case, the software itself is the agent, and when it sends a truck down a particular street, that's its action. The environment is the entire city, with all of its crazy, unpredictable traffic. Now, if a delivery is super fast, the agent gets a big reward. But if it gets stuck in a massive traffic jam, that's a penalty. So after thousands and thousands of deliveries, the software just learns. It starts to get an intuition for the city's traffic patterns. It figures out which roads are a nightmare at 5 p.m., which shortcuts are actually worth it, and it does all of this without a single human ever having to write a rule for it. It learns purely from experience. Okay, so this brings us to the ultimate endgame here. After all of this trial and error, after millions of these learning loops, what is the agent actually trying to accomplish? The goal is for the agent to figure out what's called an optimal policy.
And this isn't just, a good strategy. We're talking about the best possible strategy. It's the perfect set of actions that guarantees the absolute maximum reward over time. So for the dog, the optimal policy is knowing to sit instantly, every single time. For that delivery software, it's having such a perfect understanding of the city that it can find the fastest route no matter what happens. And that really leaves us with a pretty mind-blowing final thought. We are building systems that can learn the perfect strategy for incredibly complex problems just by trying things out and learning from the consequences. So if an AI can find the optimal policy for something as chaotic as city traffic, what's the next big problem it could solve for us? Think about it. Complex systems in medicine or climate science or even economics. What could it learn to optimize for us next? The possibilities are, well, they're truly staggering.